Hello students! So this video here, this little mini lesson is about angle terminology and relationships. So guys, in this video we're gonna look a little bit closer at angles and certain types of angles and what types of relationship those types of angles have and what we can do, what types of problems we can kind of do with these angles. And with the terminology and things like that, before we actually talk about, because in the very next lesson we'll get to angle terminology with equations, but again in this lesson here we're not quite going to get to the part where we're solving equations. All right, so let's go ahead on and get started with this one here. Okay, so if you guys remember in our latest video or our most recent previous lesson, we introduced to you guys what an angle is, and so we said that an angle is formed by two rays with the same shared endpoint extending in different directions. So again, those two rays, they have a shared endpoint and they extend in different directions. And guys, the rays are known as or referred to as the sides of the angle, and the shared endpoint is known as the vertex. So again, we had introduced angle already and what an angle is in our most recent previous lesson and in our most recent previous video. Okay, so folks, there are four basic types of angles, and most of you probably already remember and know exactly what those four basic types of angles are. We're just going to discuss those very briefly. And I know in our last video, or our most recent previous lesson, that video, we introduced to you guys right angles. And again, like I said, most of you probably already knew about that. But again, folks, that's one of those basic types of angles. But again, there are four basic types of angles, and we're going to look at those now. Okay, so again, guys, there are four basic types of angles. Okay, and most of you, and I know at least most of you that are enrolled in my class, my students enrolled in my classes at our school, most of you should at least remember these types of angles. And this should not be something that is new for you. But just in case there's somebody there that does not remember them, or that needs a little refresher or reminder, we've got acute angles. And guys, again, acute angles are those angles that have measures between 0 and 90 degrees. So again, the measure of acute angles is going to be greater than 0, but less than 90 degrees. Greater than 0 degrees, but less than 90 degrees. All right, then we've got right angles. Okay, right angles. Those are your angles that have exactly 90 degrees. Those angles that measure exactly 90 degrees, folks. And again, guys, all right angles will measure exactly 90 degrees. Okay. Next, we got obtuse angles. These are angles that have measures between 90 and 80 degrees. Sorry, between 90 and 180 degrees. So again, the measures for obtuse angles will be greater than 90, but less than 180 degrees. And then, guys, we have straight angles. These are angles that occur when opposite rays. And again, guys, opposite rays are rays that extend in opposite directions. So straight angles occur when opposite rays with the same vertex form a straight line. So here, guys, you can see that we've got opposite rays that are forming a straight line. And guys, a straight line always measures 180 degrees. So guys, here with a straight angle, you've got two opposite rays that have the same vertex, and those opposite rays form a straight line. And guys, a straight line always measures 180 degrees. So guys, these are the four basic types of angles. Okay, so folks, next up we've got to talk about how we name angles. It's really not going to do you guys much good. If you know like the different types of angles, and even the other types of angles that we'll talk about later in this same video. It really won't do you much good at all to know about all of this stuff if you don't even know how to basically name angles. Or if you're given diagrams and they tell you that you're talking about angles such and such and such and such, if you don't even know how these angles are named, you won't know which angles they're talking about, because you don't have the basic information, that sure foundation that you need to really know what they're talking about. So right here, we're trying to build your foundation of the knowledge that you need before we go any further. So folks, you need to know how to name these angles. Trust me, I ain't wasting your time, and I'm not wasting my time. You need to know. Okay, all right, so guys, again, the different ways that we can name angles. The first way, or one way, we'll put it like that, one of the ways that we can name an angle is by using a number that is written in the interior, and of course by interior we mean that is written in the inside of the angle. And guys, that number, if you see a number written on the inside of the angle without, I repeat, without a degree symbol. Everybody knows what a degree symbol, right? Like if we were talking about 38 degrees, that little degree symbol like that right there, you see it? You see what I just wrote? 38 degrees. We're not talking about a degree symbol with the number, because you can't use 38 degrees as the name of an angle. Okay, so if you see a number written on the inside of an angle that has a degree symbol, yeah, you can't use that one as a name for it. All right, so I'm making this real clear for you. Okay, all right. So in order to use a number that's written on the interior of an angle, that number has to be written without a degree symbol. I repeat, without a degree symbol. Not with the degree symbol, but without a degree symbol. Okay? 38 degrees, we're talking about a number that's written without a degree symbol, like what you see here in the diagram that we've got, where we see the number 1 written there. Yeah, and it does not have any degree symbol there, right? So we can use that number to name this angle, and we can call that angle angle 1. Guys, I'm going to erase this whole 38 degrees thingy, but I just wanted to make sure that you got that. Okay, if you're going to use a number that's on the inside of an angle, make sure it does not have a degree symbol. All right, without a degree symbol. And folks, guys, a lot of times they'll use a symbol. They'll use a certain symbol to represent that we're talking about an angle. So like if they wanted to say angle 1, that symbol sort of kind of looks like a less than sign, and I don't want you to get confused with the less than sign. But again, folks, in this context, if you see a symbol that looks like that, and it just has a number written there like that, and we're definitely talking about, in this context where we're talking about angles, then this symbol represents angles, guys. Is again, even though it looks like a less than sign, guys, trust me when I tell you, it's not a less than sign. It's only a less than sign if you had something like this right here. If you had a number to compare it with, if you had something to compare it with, like 5 is less than 7. You get what I'm saying? If it's written like this right here, then that this is a less than sign. 5 is less than 7. If you got something to compare it with, I'm going to erase that less than sign right here. 5 less than 7. We ain't got nothing to compare. We don't have anything to compare this right here with. That's just angle 1. Okay, when you see that symbol like that. All right, I'm going to erase this here too. Alright, so again, that's one way you can name an angle. Another way you can name an angle is you can use its vertex. You can use just the name of its vertex. And remember guys, that a vertex of an angle is that point where the two rays meet. Okay? Remember, an angle is formed by you having two rays that have a common endpoint. So the vertex is that common endpoint for those two rays, or for those two sides of an angle. So again, guys, you can use its vertex. And guys, in the diagram that you see over here, right here to the right of what I'm talking about, that common endpoint for those two sides, or the vertex that we see there, is point R. So guys, we can use that name right there. We can use R, that vertex, as the name of this angle. And so, but guys, you can only use that vertex as the name of an angle only if that angle does not share its vertex with another angle. So guys, you can only use the vertex, like what you see here, angle R. You can only name this angle R if it is the only angle that has that vertex. Okay, if there's another angle in there that shares that vertex of point R, then you cannot use point R, or you cannot call this angle R. Okay, all right. So that's the second way to name angles. There's another way to name angles. Here we go. We can use 3 points, and guys, if you use 3 points, those 3 points are going to be including a point from each ray. In other words, guys, a point from each side of the angle. So you see over here in this diagram where you see that point right there, point A, that's on this side of the angle, and then you see this point right here, point D, that's on that side of the angle. That's what I mean when I say including a point from each ray, or from each side of the angle. We're talking about like point A. Oops, excuse me, I didn't mean to do all that. Okay, all right. Okay, all right, okay, all right, where we at? Excuse me, y'all. All right, so again, guys, you can use 3 points, including a point from each ray, or in other words, a point from each side of the angle. And guys, if you're going to use 3 points, you have to place the vertex in the middle. So again, guys, if you were looking at this angle that included the 3 points, or if you followed along with those 3 points, the 3 points A, see that? B, see that? D, if you followed along those 3 points, that angle, A, B, D, right? You would have to put the vertex in the middle if you were going to name that. So that angle that follows along with those 3 points, A, B, D, you could name that angle ABD with the vertex B in the middle, or you can switch the order of those three points, and you can name that same angle DBA. But again, folks, you have to make sure that the vertex B is in the middle. All right, and so that's the way you would name that angle that you see right here, following along those three points, A, B, D. And there's 2 different ways you can name that angle, right? You should know which angle I'm talking about. All right, anyway. All right, the other angle that's over here in this diagram, if you were using 3 points to name that one, with the 3 points that you see here, these 3 points, D, B, and C, right? So if you were going to use those 3 points to name this angle that you see right here, and you should know which angle I'm talking about based on those 3 points, if you follow along those 3 points, D, B, and C, you should see which angle we're talking about here. All right, so again, if you were going to use those 3 points to name that angle, you can name that angle DBC, and again with the vertex B in the middle. Or you can switch the order of those 3, and you can name that angle CBD. Okay? All right, so now, guys, if you were going to use 3 points, or really the only time that you would really need to use 3 points to name an angle is really, guys, if you have an angle that shares its vertex with another angle. So guys, this method of naming an angle where you're using 3 points, this is the way that you got to name an angle if that angle shares a vertex with another angle. You see this diagram right here, and you see how for this vertex B, there are 2 different angles that are sharing that same vertex. All right, so guys, if you got that right there, you got more than one angle that's sharing the same vertex, like here in this diagram where I've got this angle B right here, then guys, you're gonna have to use this method of naming angles, and you're gonna have to use 3 points with the vertex in the middle. All right, guys, that takes care of naming angles. Okay, so guys, the special types of angle pairs. There are special types of angle pairs that exist, and so in this video we'll talk sort of about 5 of those special types of angle pairs, and we're gonna have to make this real brief because we almost out of time here. But anyway, guys, one type of special angle pair is adjacent angles. Guys, 2 angles are adjacent angles if they are side by side with a common, or in other words, by common I mean shared. So if they're side by side with a common or shared vertex and a common ray or a common side. So you see here, like here in this diagram that you see that's kind of boxed in with the blue. These 2 angles are adjacent angles because they're side by side. They have a common vertex, a shared vertex, and they have a common side, right? So any 2 angles that are like that, where they're side by side with a common vertex and a common ray or common side, are considered adjacent angles. Okay, awesome. Next up, guys, the next type of special angle pair is vertical angles. Guys, 2 vertical angles are non-adjacent angles that are facing opposite directions. And guys, these vertical angles are only formed when 2 lines intersect. I'm trying to show you, even though they got a little diagram over here, let me just try to show you a little something right here real quick. Yeah, let me put like a little something right here. Put a little something together, line, and then let me put another little line. Where you at? Where you at, ruler? There you go. Give me another little tiny little angle here, and another little line. So you got 2 lines that intersect. Give me a bigger angle than that. Come on. There we go. 2 lines that intersect. Right there. So whenever you got 2 lines that intersect, like that right there, just like that right there, you're always going to have vertical angles that are going to exist, guys. And so if you look really carefully, all right, I'm going to do something real quick, and I'll erase these once I'm through with them. But just to make my point, guys, so if you had to tell me which angle was opposite, which angle is sort of facing the opposite direction as this one, and that's also not adjacent to it, right? The only angle that's facing the exact opposite direction as this one and that's not adjacent to it is that angle, right? Those 2 angles there would be considered vertical angles, right? You get what I'm saying? So it happens when when you got 2 lines that intersect. But again, the 2 angles that we're talking about are not adjacent. Okay, I know that's a little sloppy. They're not adjacent, and they're not adjacent, and they're going to be facing opposite directions. Okay, so if we were looking at this angle, right? This angle here, the only other angle in there that's not adjacent to it, literally the only other angle in this out of these 4 angles that's not adjacent to that one and facing the opposite direction of it is this one, literally. So these 2 angles would be considered vertical angles. You get what I'm saying, y'all? I'm gonna erase this right here, but again, all right, just to show you something other than this diagram that I've already got over here, where I've let you know that angle 1 and angle 2 are vertical angles, and angle 3 and angle 4 are vertical angles. Waste the moon, though. Let me erase this right here. Bye-bye. So long. There we go. We got to hurry this up, folks. All right, next up, complementary angles. Complementary angles, most of you guys probably already remember complementary and supplementary angles, but guys, please pay attention because there may be some new information that you did not know already. And I'm sure that there may be some folks that may not be in my class enrolled in my class at our school that may not even know what complementary or supplementary angles are anyway. But anyway, guys, complementary angles are two angles whose measures have a sum of 90 degrees. And guys, and this, for my students enrolled in my class, you may not have known this information here. Each angle, when you have two complementary angles, each angle is called the complement of the other. Okay? Alright, and then the supplementary angles are two angles whose measures have a sum of 180 degrees. And when you have two supplementary angles, each angle is called the supplement of the other. Alright, so guys, over here to the left, alright, so guys, I've got all those diagrams there on the right side. Over here on the left side, I've got another diagram for supplementary angles. And this also applies for complementary angles too, guys. Complementary angles can be either adjacent, like over here on, okay, so on the right side, this diagram on the right side that's pointing to with the complementary angles. You see angle 1 and angle 2 on the right side here. For the complementary angles, I've got an arrow pointing to that right there. From complementary angles on the right side, an arrow that's pointing to complementary angles on the right side. You see it? I'm talking about angle 1 and angle 2 over here on this side. Those two complementary angles are adjacent to each other. But guys, where you see the 47 degrees and the 43 degrees there, those two complementary angles are not adjacent. Okay? Alright, the same thing applies when we have supplementary angles. Okay? You see this angle that's pointing here on the left side? Yeah, you see it. I got it selected right there. Okay? So the same thing applies for supplementary angles. You can have non-adjacent supplementary angles. Again, supplementary angles that add to 180 that are not side by side, that don't have a common vertex, that don't have a common side. But anyway, you can have non-adjacent supplementary angles, or you can have adjacent supplementary angles. So guys, here's the deal. When you do have adjacent supplementary angles, they're called something different. Now, they're still supplementary, but they are also called something different. Two angles are a linear pair. They are called a linear pair if they are adjacent and they form a line. If they are adjacent and they form a line. Okay, yeah, you know what I'm trying to spell. If they are adjacent and they form a line, they are called a linear pair. And so guys, a linear pair is always supplementary because every straight angle measures 180 degrees, guys. And again, if the angles are supplementary and adjacent, then they definitely are, or they definitely form a straight angle, or because they form a straight line. All right, so these are the special types of angle pairs: adjacent angles, vertical angles, complementary angles, supplementary angles, and linear pairs. Okay, so guys, let's look at an example, or just an example, a few examples here, and we're going to go ahead on and do this here. Now, I hope that this isn't too small for you to see, but again, folks, we're going to go ahead on and do this here. All right, so guys, here it says, and we're using this diagram that's right there. It says which other two angles are hold on real quick. It says which other two angles are supplements of angle 3. All right, so which other two angles are supplements of angle 3? So guys, when you look at angle 3 here, there's only two angles that would be considered supplements. And let me just show you real quick, super real quick, because I don't have a whole lot of time. I'm gonna try to show you with this highlighter here. So if you're looking at angle 3, guys, there's two lines that are. So one line that's kind of looking at angle 3 is that one there, right? So the one angle that's a supplement with angle 3 is angle 4, right? So that's that one. Okay, we gotta hurry up. All right, so I'm gonna see if I can erase that line. All right, the other line that's dealing with angle 3 is this one here, right? So for that line, there's only one supplement for that's with angle 3. And again, guys, if you're looking at angle 3 and angle 2, or angle 3 and angle 4, and the reason why I highlighted that line is because they form a linear pair. When they form a line like that, and again, a linear pair is always supplementary. Okay, so that's why I highlighted that line. Okay, and we were looking for supplements in there. All right, so angle 2 is also a supplement of angle 3. All right, I'm going to erase that line again now, this as well. Okay, it says list a pair of vertical angles. Okay, guys, so we said the vertical angles are only formed when we have two lines that intersect. Well, guys, there are literally only two lines here. Only two lines on this diagram. These two lines right here. So, guys, if we were going to identify the vertical angles, it would be this angle right here. Okay, hopefully you see where I got that dot. Let me try to make it a little bit bigger for you. This angle right here and this angle. Angle 2 and angle 4. Okay? That are opposite from each other and that are non-adjacent based on those two lines intersecting. So angle 2 and angle 4, we gotta hurry up. Okay, let's see here. What's the measure of angle 5? Okay, this one's fairly simple. Okay, so folks, you see this right angle here? That right angle right there? And then you see, okay, I'm going to erase that. All right, but you see that right angle symbol, and you see this line right here. So when you look at that, and you see this right angle symbol right here. All right, so this angle is 90 degrees, right? So for this whole line, okay, yeah, that's sloppy as I don't know what. For this whole line. Let's try that again. All right, for that whole line, remember, guys, that the measure of any line is 180 degrees. So if part of that is 90 degrees, that means that this part that's in angle 5 has to be 90 degrees as well. Hopefully that makes sense, guys. Okay, we almost out of time, so if it don't, I really don't have any other way of explaining that to you. All right, I'm going to erase all of that right there. Okay. All right, but again, that was 90 degrees. All right, find the measure of angle 4. Oh, and by the way, guys, thank you. That's what I wanted to say here, guys. When they're asking you to find the measure of some angle, this notation right here, where you see the M in front of that, like the measure of angle 4, that there, it stands for the measure of angle 4. Oops, that ain't no G. Come on now. The measure of angle 4. All right. Okay. All right. We're gonna have to just go with. We're gonna have to go with these first 5, and yeah, because I don't have enough time to go over that last one at the moment. All right, so find the measure of angle 4 if the measure of angle 1 is 39 degrees. All right, so let's do this one, and then I really got to go. All right, so guys, angle 4 is this angle right here. And so guys, it says to find the measure of angle 4 if the measure of angle 1 is 39 degrees. So let me write that in here. At the measure of angle 1 is 39 degrees, right? So this part here is 39. Well, guys, looky here. Angle 1 and angle 2 are complementary angles. And angle 1 and angle 2 together have to add to 90 degrees, right? So if they're complementary angles and they add to 90 degrees here, these two angles are a total of 90 degrees, right? So if we know that part of that 90 degrees is 39 degrees, then we can figure out the other part of it, right? So this other part of that 90 degrees here it has to be 51 degrees. Now, so if angle 2 is 51 degrees, all right, so now we're talking about angle 2, right? If angle 2 is 51 degrees, then guys, this angle that is directly across from angle 2 that other angle right here, that's a vertical angle. Yes, angle 4 and angle 2 are vertical angles with each other. Angle 4 and angle 2 are vertical angles. And vertical angles, guys, are always congruent. Vertical angles are always congruent to each other. You may not have known that, but I'm letting you know right here, right now. Vertical angles are always congruent. Okay, I've already got that written. Give me a sec here. Let me just write always congruent, because I got to go. I don't want this alarm to be set on me. This alarm to go off on me. Vertical angles, guys. Vertical angles are always congruent to each other. So if one of these angles is 51 degrees, that means that the other angle here has to be also 51 degrees. All right, guys, that is it. That's all. That's all I got for you. I hope that this has been helpful to you. That's all I got. Guys, the only other thing I got for you right here, you see these little curved marks here on these two angles? Those are congruency marks for angles. So they're not quite like the little congruency marks that we have for side lengths. Those congruency marks sort of look like little tick marks, but these are sort of like little curved markings that sort of look like that there. But anyway, sort of look like parentheses. All right, but those are congruency marks for angles that let you know that those two angles are congruent. Okay. Alrighty, that's it. I hope that this has been helpful. Gotta go. Bye-bye. That's all, folks. Adios. Au revoir.